Everything in and around us is made up of atoms. Atoms combine to form molecules. Our example, hydrogen atoms combine with oxygen to form water molecule H2. Atoms and molecules had extremely small house bond. Proton contains 1 trillion hydrogen atoms. Diameter of a water molecule is 0.3 nanometer, that is 10 to the power -9 meter. Because of extremely small size of atoms, it is very difficult to count them, and in order to observe, manage, and deal with these small atoms and molecules, chemists came up with the term mole. Mole, not the animal, nor the spike, neither the one on your uncle's face. In chemistry, mole is just an average. As we buy socks in pairs, eggs in dozens, paper in a ring, similarly, in chemistry, deal with atoms in the loot. As a pair means 2, a dozen means roof, a ring means 500, and 1 mole is essentially 602.214.179.000.000.000.000 of something. To make life easier, write it as 6.0.2 multiplied by 10 raised to the power 23. So, if someone asks you for 2 moles of water, you would know there has import 2 multiplied by 6.02 multiplied by 10 raised to the power 23 water molecules. Experiments are so much like. Let's see some moles in action by doing a simple experiment with gems and laddus. Yummy! Take a big beacon and put as many marbles in that container as possible. Now try to put some number of laddus in that containers. Is this possible? However, gas molecules do not behave like fluids. If you take the hydrogen and oxygen in same volume vessels, you can put the same number of molecules. In 1811, an Italian scientist, Amedeo Avogadro, observed this behavior of gases and proposed that the volume of a gas at a given pressure and temperature is proportional to the number of atoms, molecules, regardless of the nature of the gas. When Avogadro first proposed this hypothesis, it was hard for people to accept it. Many years later, other scientists experimentally determined that Avogadro was right, and a fixed volume of gas contains 6.02 multiplied by 10 raised to the power 23 atoms, and it was called a worm. Since Avogadro was the first one who observed this, a mole is also known as Avogadro's constant. Since now you know what a mole is, can you tell me the number of moles in 360 grams of water? To answer this correctly, you need to know mass of 1 mole of water engrossed. We use the periodic table to find out the mass of atoms. For example, oxygen. Its the number is 8, which is written at the top of the symbol, and the number written at the bottom represents its atomic mass. Molecular mass is determined by adding atomic mass of individual atoms present in a molecule. Experimentally, chemists can determine that mass of 1 mole of an atom or molecule is equal to its atomic full molecular mass in grams. 18 grams of water, 55 grams of iron, 32 grams of zinc, 58.5 grams of salt, 197 grams of coal, and 4 grams of iron. Each contain 1 mole of atoms, molecules. Using this logic, we can find number of moles of any substance by adding given mass of the substance with its molecular mass. So number of moles in 360 grams is equal to 360 divided by 18 grams of water. The second way of finding moles is by knowing the exact number of particles. For example, if you have 3.01 multiplied by 10 raised to the power 23 oxygen molecules, You can find the number of moles by dividing it with Avogadro's constant. So in this case, they have 0.5 moles of oxygen. I also have a third way of finding watts for gases. If you are given volume of any gas in liters at standard temperature and pressure, then its number of moles can be determined using the formula. Given volume upon 22.4 pi hope, moles will not bother you anymore.